students, today we will discuss about the hydrocarbons. If we divide the word hydrocarbon, then it will divide into the hydro and carbon. It means it consists of the carbon and hydrogen only. And these are example are methane, ethane, propane, etc. There are two type of the hydrocarbon: saturated hydrocarbon, unsaturated hydrocarbon. Saturated hydrocarbons. Those hydrocarbons which contain single bond. Those hydrocarbons which contain single bond only are called the saturated. Saturated means single bond. SS, saturated single bond. And example is methane, ethane, propane, butane, pentane, hexane, and so much. Unsaturated hydrocarbons. Those hydrocarbons in which valency of the carbon is satisfied by the double or triple bond are called the unsaturated hydrocarbons. Example: ethene, ethyne, propine, propene, butene, butane, etc. Now these hydrocarbons are divided into three types according to the bonding: alkane, alkenes, and alkynes. Alkanes. Alkanes. As the name shows, alkanes, anes, they have the suffix anes. Anes, they have the suffix anes. Ines, they have the suffix ines. And they show the single bond. They show the double bond. They show the triple bond between carbon and hydrogen atom. Formula of alkane is CnH2n plus 2. CnH2n plus 2. Alkene's formula is CnH2n. Alkyne formula is CnH2n minus 2. Here n is the counting number of 1 to 9. If we put the value of 1, 2, 3, 4, 1 to 9, then they form the formula methane, ethane, propane, butane, pentane, and hexane. Now methane. Methane CH4. It has the chemical formula CH4. Carbon share 4 valence electron with the 4 hydrogen. Ethene C2H4. Here carbon showing double bonding with the other carbon and share 2 valence electron with the hydrogen. Ethyne. Ethyne C2H2. Here carbon share triple bonding with the carbon and 1 electron with the hydrogen. Now what is functional group? It is the atom or group of atoms or relative part of compound which largely determine the chemical properties of a compound. This group of atoms determines the chemical properties of a compound. Here are the 4 functional group in the 10th class. OH, alcohol, CHO, aldehyde, C double bond O, ketone, C double bond O, OH, carboxylic group. Homologous series. It is a series of the compound which are derived from the same general formula, having same functional group, similar chemical properties. Homologous series has same general formula, same functional group, and similar chemical properties and show gradation in the physical properties. Each member differ from the successive member by the CH2 group. The difference in the molecular weight between the two successive members is 14U. Now what are the characteristics of the homologous series? They have same general formula. They have same functional group. They have similar chemical properties. They show gradation in the physical properties like melting and boiling point, increase with increase in the molecular weight. Now IUPAC naming. IUPAC full form is International Union of Pure and Applied Chemistry. Now what are the ruling for the IUPAC naming? Rules are: select the possible longest chain. First, select the longest possible chain. You can select here 1, 2, 3, 4, 5. This is the longest. But here the functional group is here. This show the alkene double bonding presence is there. That's why we will starting from the functional group first. The number of the carbon atom in the parent compound is denoted by the proper prefix. Proper prefix. Parent chain contains 6 carbon. If this contains the 1, 2, 3, 4 carbon, then it is methane, ethane, propane, butane. Methane, ethane, propane, butane, then butane. But due to double bonding, it is butene. And if 6 carbon is there, then we can say the hexane. Group attached to the parent chain are indicated by their names and prefixing the number of carbon to which they are attached. Counting of the carbon chain is done in such a way that the carbon attached the alkyl group or functional group get the minimum number. We can mark from here 1, 2, 3, 4. But here the functional group is at the third position. But if we started here, then the functional group is at the first position. If more than one identical group are attached to the carbon atom, these groups are indicated as di for 2 and tri for 3. If 2 methyl group is there, then according to the numbering, at 2 position methyl group is present, 3 position methyl is present, then we can write here 2, 3 dimethyl butane. Methane, ethane, propane, butane. If we mark the IUPAC naming here, then first select the longest chain. 1, 2, 3, 4. If we selected 1, 2, 3 short chain, 1, 2, 3, 4. It is the longest chain and this is also the longest chain 1, 2, 3, 4. But if we write 4 here, then methyl group is here at the same position after the third. That's the 2, 3 methyl. And methane, ethane, propane, butane. Butane is there and 2, 3 dimethyl. 2, 3 dimethyl. For double and triple bond, suffix "-ene" and "-ine" is used. Just starting from the here, first select the longest chain 1, 2, 3, 4. Now see the functional group and here we see that functional group is in between 2 here and 2 here. Methane, ethane, propane and butane. First is butane, but due to doubly bonding it is butene and "-ene" is this functional group is light at the position of 2. Then we can write but 2 ene. Now alcohol. Alcohol has the functional group OH and write the suffix -ol. If we take the methane, then methanol. If we take the ethane, then replace the E with the O. Ethanol, methanol, ethanol, propanol, butanol, pentanol, hexanol. All these are the alcohol. Now we write the name of this formula. First C3. Write down 3 carbon at first and now write down the functional group on any side and then satisfy the valency with the hydrogen. And here 1, 2, 3, 4. 4 carbon, 4 tetravalency are satisfied of this carbon. 1, 2, 3, 4. And here also the tetravalency of carbon satisfied 1, 2, 3, 4 and tetravalency of this is satisfied and hydrogen should be 7. 1, 2, 3, 4, 5, 6, 7. Now write down the name 1, 2, 3. This is the longest chain. At first position ol group. And if we write down the propane, this E is replaced by the OL, propanol. Propanol 1 at one position functional group is there, then 1 propanol or propanol 1. Next functional group is aldehyde. Functional group is CHO. And for ketone C double bond O. And if we write down the naming, then at the end of the methane E is replaced by the ul. Al, al. This is this is the aldehydic group. Aldehydic group. Now first select the longest chain 1, 2, 3. Methane, ethane, propane. Now propane. Replace E by al. Propanal. 1 propanal or propanal 1. Now ketones. Ketones have the functional group C double bond O and write down the suffix 1. 1. That is, now we will write down the name of this compound. First select the longest chain 1, 2, 3, 4, 5. 1, 2, 3. The functional group is at the same position on both the sides. So we can write anywhere. And longest chain is 5. Methane, ethane, propane, butane, pentane. Now write down pentane and at the third position, there is the functional group 3 pentane. Replace E with the ONE, 3 pentanone. Fourth group is carboxylic group. C double bond O, OH. C double bond O, OH. And suffix right here is oic acid. Oic acid. Now write down the name of this compound. First select the longest chain from the side of the functional group, and this is the functional group of the carboxylic group. Now methane, ethane, propane. Propanoic acid. 1 propanoic acid or propanoic acid, both are correct.